Yes, you're welcome to our new topic. In this topic, we are introducing something that is very important in our physical chemistry, and we are calling them the ideal and the non-ideal solutions. These type of solutions are miscible mixtures. Now, in our introduction, we want to know what leads to miscibility of solutions. You get a solution like you get water, you add it to ethanol, and you get a miscible mixture. When someone in chemistry talks about a miscible mixture, what do they mean? So we are saying what we call miscible mixtures are uniform solutions in which the components of the mixture combine in all proportions to form one layer. Previously, we discussed immiscible mixtures, and we said for them they form two layers. Now, these ones, they form one layer. The components, you have component A mixing with component B, and the result is a single layer, meaning that the components have accepted to combine in all proportions so that we form one layer, and we shall describe that as a miscible mixture. Our common examples of such mixtures would contain, for example, someone could talk about ethanol combining with water. We shall form a miscible mixture. Someone could talk about two organic solvents like benzene, and methyl benzene. These ones will mix in each other very well. Someone would talk about things like carbon tetrachloride, carbon trichloride, that's chloroform, carbon trichloride, mix it with an organic substance like propanol. These are examples that we shall use. We can even have an acid mixed with water, nitric acid, mix it with water. You will see that these ones will form a miscible mixture. We can have even other alcohols like methanol. Mix methanol with water. This is a miscible mixture. But now the question is, we can rate the list of miscible mixtures endlessly, but the question is why or how, what brings the components to accept and form a miscible mixture? How is miscibility possible? Okay? How does miscibility occur? Miscibility occurs as a result of two components accepting to form a common intermolecular force of attraction. two miscibility occurs as a result of two components relating with a common intermolecular force of attraction. Relating with an intermolecular force of attraction. Meaning that if we had, for example, liquid A, if this is liquid A, and we add to liquid B, what is present in liquid A are molecules of A interacting with molecules of A. And then here, molecules of B interacting with molecules of B. And so, the result, if the result is to be a miscible mixture, one layer, then molecules of A must find a way of interacting with molecules of B. That's why I'm saying miscibility occurs as a result of two components relating with a common intermolecular force of attraction. So this is the mixture of A and B. For us to form a uniform layer, A molecules must interact with molecules of B through a common intermolecular force of attraction. So here, now we can say that molecules between A and A, we call these molecules the cohesive forces of attraction. Molecules between similar atoms, we call these ones cohesive forces of attraction. Now, molecules between still molecules of B and B, they are also cohesive. So meaning molecules between the pure components, intermolecular forces of attraction between molecules of the pure components, we call them the cohesive forces of attraction. Now, when we mix the two, we get an intermolecular force between different components, and we call these ones here adhesive. Forces of attraction between the different molecules. So the ability of two different liquids to form, and the ability of two molecules of different liquids to form an adhesive force of attraction is what makes miscibility possible. Okay? So now we are saying we have two things coming up, is that we have cohesive, you see, intermolecular forces of attraction, what we call intermolecular forces of attraction. Intermolecular forces of attraction may be cohesive if they are between molecules of a pure component. Or they can be adhesive if they are between molecules of the mixture. If they are between molecules of the mixture. So we have what we call these intermolecular forces. Now, the cohesive forces of attraction may be van der Waals, may be also hydrogen bonds, depending on the structure and nature of the molecules. So intermolecular forces can as well be intermolecular forces. I mean, they can be hydrogen bonds, they can be van der Waals forces of attraction. So that is the reason why we can have miscibility. We are saying miscibility occurs as a result of components relating with a common intermolecular force of attraction. Two components, A, B, decide to relate by formation of a mixture, and AB must be formed, the intermolecular forces of attraction between molecules of A and B. Should they refuse to relate, then we shall form an immiscible mixture. So in all these examples we are seeing, there is a common intermolecular force of attraction between ethanol and water. Water finds a way of relating with the ethanol molecule such that we have an adhesive force of attraction between the mixture. The same happens to benzene and methylbenzene. The same would happen to trichloromethane and propanone, water and nitric acid, methane and water. There is always an intermolecular force of attraction, which we are calling the adhesive. Now, after knowing how miscibility arises, we have two types of miscible mixtures. According to this topic here, we are saying, or we are going to say, that there are two types. There are two. We are going to say that miscible mixtures can be divided into what we call ideal and non-ideal solutions. So ideal and non-ideal solutions all come from miscible mixtures. So now, if miscible mixtures can be divided into ideal and non-ideal, we would now want to know, when do we call a solution ideal? And what are some of the examples of an ideal solution? So I'm going to write my subheading here is ideal solutions. So what do we call ideal solutions? What do we call ideal solutions? Now, an ideal solution, we have talked about adhesive and cohesive forces of attraction. A solution is described to be ideal if the magnitude of the cohesive forces of attraction between the pure components is equal to the magnitude of the adhesive forces of attraction between molecules of the mixture. In other words, the forces of attraction between A molecules and the forces of attraction between B molecules is equal to the forces of attraction between A and B. That the magnitude in the cohesive forces of attraction between molecules of the pure components is equal to the magnitude of the adhesive forces of attraction between molecules of the mixture. And that will give us an ideal solution. And because of that, an ideal solution will be described to follow what we call the Raoult's law. It will be described to obey a law of solutions, what we call the ideal solution. What we call the Raoult's law of ideal solutions. If that happens, so now there are two things we are normally asked. We are asked to define what we call an ideal solution, but then sometimes we are asked to explain what is meant by the term an ideal solution. So if we are asked to define, it will be very simple. We shall say that this is a miscible mixture or solution in which the cohesive forces of attraction, in which I can include the word magnitude, in which the magnitude of cohesive forces of attraction between molecules of the pure component are equal to the magnitude of the adhesive forces of attraction between molecules of the mixture. Therefore, this mixture will obey Raoult's law of dilute solutions. So now, we are saying this is our definition of what we call the ideal solution. That is a miscible mixture in which the magnitude of the cohesive forces of attraction between molecules of the pure component are equal to the magnitude of the adhesive forces of attraction between molecules of the mixture. And thus such a solution will obey Raoult's law. That means we can briefly, before we look at the explanation of the term, look at what we call characteristics. Characteristics of an ideal solution. The first characteristic of an ideal solution is in the definition. Cohesive forces are equal to adhesive forces. 2, in such a solution, when it is being formed, there is no heat loss or heat gain. No change in heat once the solution is formed. There is also no change in volume expected. No change in volume expected when the solution is formed. 3 or 4, the solution will obey. The solution obeys what we call Raoult's law. These are the 4 characteristics that help us now to explain. And in the next lesson now, we are going to see if someone asked you to explain what is meant by the term an ideal solution, what do you give as your answer to the explanation? This is the definition, these are characteristics. In the next lesson, we shall begin from there. See you there. Thank you.